Today's lesson is the Pythagorean Theorem. Our objectives is to use the Pythagorean Theorem and its converse to solve problems. We're going to use the Pythagorean inequalities to classify triangles. So is it going to be a right triangle, a obtuse triangle, or is it going to be an acute triangle? So, identifying the Pythagorean Theorem. Well, that's example 3. I don't know why that happened like that. Use the Pythagorean Theorem. Okay, so we're going to find out the formula. So down here at the bottom is, that's the converse of it. I don't know why it's doing that. Okay, so we'll do example 1. It's right here. For your information, the formula for Pythagorean Theorem is a squared plus b squared equals c squared. Now, on a triangle, a right triangle, the A and B are what's called your legs. So those are the ones that are next to the right angle. They're your legs. And then you have your long line, and it's opposite the right angle, and that's called your hypotenuse. And that is your C. So using this formula right here, your Pythagorean Theorem, we are going to find what x equals. And they want you to answer your question, answer in simplest radical form. That is your square root radical form. Okay, so I'm going to have a squared, which a and b are 6 and 4. Does not matter which one you do first. So 6 squared plus 4 squared, a squared plus b squared equals c squared. That's x squared. And then you do your squaring. So 6 times 2 is 36. 6 squared is 36 plus 4 squared, which is 16, equals x squared. 36 plus 16 is 52, equals x squared. Now to get rid of a square, you square root. And you, okay, now x equals something, because that's what we're trying to find. X equals, what x equals. Now we're going to break up 52. You have to remember from last Algebra 1 how you do this, but I'll remind you. What's a perfect square that can go into 52? Well, 4 can. 4 times 13. Now, what's the square root of 4? Square root of 4 is 2. And then what's left over is square root of 13. Keep the 13 inside. Don't put a 2 square root of 13. It just leave it 2 square root of 13 equals x. Let's try B. I'm going to erase this so I can have some space. I need some space. So I have A and B are these two, and this is C. So you have 5 squared plus x minus 1 squared equals x squared. If I look at this, this looks like I need to either FOIL of some sort. So this is going to be 25 plus. Then I'm going to change this color to red, and I'm going to go up to the top of the page, and I'm going to do x minus 1, x minus 1. There's another way of doing this, but we'll just do FOIL. X times x is x squared. X times negative 1 is negative 1's x. Then down here is another negative 1x. And then negative 1 times negative 1 is positive 1. Remember to put these two together. So it's going to be, your foiling is going to be x squared minus 2x plus 1, and then equals x squared. Put like variables together. So it's going to be, or numbers together, 25 plus, oh no, sorry. My like terms are 25 and 1. So it's going to be x squared minus 2x plus 26 equals x squared. This x squared is lonely, so I'm going to bring the x squared from the left over to the right. So I'm going to subtract x squared to both sides. I'm sorry, I'm going to go below the words, and now it's going to be negative 2x plus 26 equals 0. Now you can either bring the 2x over to the other side or bring the 26. It doesn't matter. I'm going to add 2x to both sides. Let's make it a positive. So it's 26 equals 2x. Divide by 2. X equals 13. That's for B on this one, right over here. All right. Now I'm going to erase the second at the bottom part so I can show you the picture that I want you to look at in the Word. Okay, safety application. So we're taking a word problem. To prevent a ladder from shifting, safety experts recommend the ratio of A to B to be 4 to 1. This is going to be 4 times bigger than B. So it's going to be 4B. We'll do 4B. So this is going to be 4 times bigger than B. So it's going to be 4B. How far from the base of the wall should you place the 10-foot ladder? So here's your ladder right here, because it's leaning against the wall. So this is a 10-foot ladder. Let's round to the nearest inch. So this is where you're going to have to do like how many feet and how many inches together. So you'll need a calculator for this one. So you're going to have, doing the Pythagorean Theorem, you're going to go 10 squared, that's your c squared, equals oh sorry, not a, that would be 4b. 4b squared plus b squared. And that would be 100 equals 16b squared plus b squared. Remember, you have to, if the 4 is inside the parentheses, you have to also do square the 4 also, so it's 16b. So it's going to be 17b squared equals 100. Divide by 17. Okay. So I'm going to show you something that how you're going to do it on your calculator. So you want to have, it's going to be 100 over 17 equals b squared. And I'm going to square root both sides. Okay. On the Texas Instruments that we're using in class, this is what you should do as when you write this out on your calculator. It's going to be in orange. You're going to put your square root sign, and a parentheses should come up. And then you're going to do 100, and then the divided by sign, 17, and then put your other parentheses. Because if not, they're going to think just 100 is being square rooted and nothing else. So make sure you also put the parenthesis around the 17. So for your decimal, 100, square root of 100 divided by 17 and put your other parenthesis. Should get you, let's round to the nearest tenth right now. So it's going to be 2.4 feet. But they want you to write it in feet and inches. So I have 2 feet, but how many inches is 0.4 of a foot? See, you have there are 12 inches in a foot, so 12 times 0.4 will get you 4.8, but round to the nearest inch, so it will be 5 inches. And there's your answer. So it will be about 2 feet, 5 inches. All right, let's try the example 3, so I have to go backwards. All right, identifying Pythagorean theorem. We're going to do the opposite. So down here at the bottom is converse. We have that if a squared plus b squared equals c squared, then it is a right triangle. A squared plus b squared equals c squared is a right triangle. Oh, maybe I have to do that after example 3. So let's look at example 3. We need to find the missing length. So that's for A, it would be this side, and for B, it would be this side. So if I look at A, which one is the C? That would be 15 because it's opposite the right angle. So I'm going to have x squared plus 12 equals 15 squared. Squared. So x squared plus 144. And Pythagorean triple, I forgot to tell you, means a whole number. All sides have to be whole numbers. So equals 15 squared is 225. I'm going to write that down for you. Pythagorean triple, whole numbers. So I'm going to subtract 144. X squared equals 225 minus 144 equals 81. Square root both sides. X equals 9. Since it is a whole number, yes, it is a, and this is your explanation, x equals 9. So you would say yes, it is a Pythagorean triple. Let's see if B is a Pythagorean triple. This time your x squared is with the c squared. So it's going to be 15 squared plus 9 squared equals x squared. 15 squared is 225 plus 81 equals x squared. 225 plus 81 equals 306. Let's not square root it yet. Then I square root. Now I have to break up my 306. And that would be 9 times 34. That's 306. 9 times 34. Square root of 9 is 3. What's left over? Square root of 34 equals x. And since this is not a whole number, it is not a Pythagorean triple. Okay, I'm going to make another video for the second half of this. Well, it's only one problem left, but we're going to talk about the converse of the Pythagorean theorem and some inequality theorems about Pythagorean theorem. So go watch the other video.